All right, in this video, we're going to look at hydrates. Hydrates are generally ionic compounds that have some water molecules bonded to them. Not very strongly bonded. They can be removed with just some heat, but they're attached in the crystal structure. And this particular one, magnesium sulfate heptahydrate, because it has 7. So each single one of these MgSO4s has 7 water molecules. And if we heat it enough, these waters are all going to sort of evaporate, boil away, whatever word you want to use. They're gone, leaving you with just the anhydrate. So if I have 4.5 grams of the hydrate, I'm trying to figure out a number of things. One, what is the percentage of water in the hydrate? And then what mass will remain if I do succeed in eliminating all the water? So let's start with the percentage of water. This is just a molar mass question. We start by adding these things up. So we say, okay, MgSO4 has 1 magnesium, 1 sulfur, 4 O's. And so we can add that up. Magnesium is 24.31, which I get from the periodic table. Sulfur is 32.07. Oxygen is 16. So we're just going to add those up as we would any molar mass. 32.07. 16 times 4 is 64. But it also has water attached to it. So it's got 7 waters attached to it. And water, if we look up and add up, is 18.02. So we're going to have to include that in the mass of the overall crystal. And that's 126.14. So the full crystal, all of it together, if we add this all up, 24.31, 32.07, 64, and 126.14, I get that the total mass is 246.52. So the full mass of the hydrate with the water is 246.52. Now, I want to find what percent of it's water. Well, water contributes this much, 126.14. So to find the percentage of water, I just take the mass that is water, and I divide it by the total mass, which I guess I already kind of looks like I wrote that out there, and then times 100 in order to make it a percent. So 126.14 divided by 246.52 times 100, I get about 51 point, I'm going to round just to 2 decimals, 0.17% water. So it's actually over half water, which is a very significant amount. A lot of hydrates aren't that much water. And so that's the quantity, 51.17% water. We'll carry that over to the next problem. So we figured out that it was 15.17% water. So I now have 4.5 grams of the hydrate, which includes the water in it. And I'm going to heat this and heat this and heat this, and I want to figure out what is left. So what I'm going to do is figure out, okay, how much of this crystal is water? So it's 51.17% water. So what that means is that for every 100 grams of this substance, 51.17 grams of it is water. And so it should be slightly over half. It should make sense. So I get 2.3 grams of water. Another way you can do this, I just did this dimensional analysis. For every 100 grams of hydrate, you get 51.17 grams of water. This was also of hydrate. You could just use a percent and say, okay, it's 4.5, and I know 51.17% as a decimal is 0.5117, and you're just multiplying that. Either way, this is how much water is there. You need to figure that out. And again, does it seem reasonable? If you have 4.5 grams and roughly a little more than half is water, it is reasonable that 2.3 grams of it is water. So just do a quick check and make sure that it makes sense. So how much is left after you heat all the water away? We're just subtracting the water lost. And so the remaining amount, the dry anhydrate, is 2.2 grams. So if you heat this long enough, all the water will kind of vaporize, and all that's remaining is the 2.2 grams of the anhydrate left. So this is basically the first kind of 2 parts of hydrates. The quiz that I have on it covers 3 different parts, so another video I'll go over the 3rd part. But anyway, this is getting us started with hydrates. So until next time, I am Derek Genova. Have a delightful day.